All right, so this is a super quick rundown of your guys' next lab. And most of these answers I just got from in the reading really quickly. So, okay, so number one would be the principle used in chromatography is like dissolves like. Um, This one right here, number two, will a polar substance dissolve better in another polar substance like water or in a non-polar substance? It's going to be a polar substance. And you can get that answer from the answer from number one because like dissolves like. So if it's polar, it's going to dissolve better in polar stuff. Okay, so moving on to number three. Consider the following. All right. So the first thing we want to check is our solvent front. That's going to be where this line approximately is. And you'll use the same one for all of them. So I would probably say somewhere in this general region, it's like 3.80. And then we can go, I don't know if you want to put a measurement for this. This could be in centimeters, millimeters, don't know. RF isn't going to have units anyways, but this does not tell you what scale it's in. So, so this is going to be our solvent front. And then you can change yours, like please change yours to something different. That's just a general reading. Unless you're reading exactly what I'm reading, feel free to change yours. I'm also viewing it zoomed out with a keyboard and I don't have a ruler. But okay. So we'll do the calculations for number one right here. Okay, so the first spot, the distance to the first spot, it doesn't really matter which spot you use. I'll go ahead and call this the first spot, and this will be the second spot. So I would say, because we're going to go to about the center, which is, right about there. Same thing here, right about there. To calculate our RF, we're going to need to go, this is for the first spot. It's going to say, I don't know, what is that, like 1.6? 0. And that's going to be divided by 3.80. So your RF is going to be, and it's listed above in the reading, it's going to be distance to center of spot divided by distance to solvent front. And that's why you keep your solvent front the same, so you're comparing it to the same thing on for all of your RFs. So, okay, so this one would be, based on my math, or my numbers chosen, 0.60 divided by, looks like I'm gonna get, oh wow, 0.421. And that's to 3 sig figs, right? It's 1.60. Now our second spot. So again, we're using the same solvent front. And this is going to be like, what, 3.45? Approximately. So 3.45. And doing that calculation, I get 0.908 to 3 sig figs. So let me write this, the first number bigger so you guys can see it, but again, yours should probably be a little different than mine because you can get a better a better reading. And then 0.908, that's going to be, let's do that second. Okay. So yeah, you're just going to go through and do this for all of these. You know, this is about center there, that's about center there, approximately center, about center, about center. So this next part, pretty important right here, number 4. For the common pigments, you need, they need to have approximately, you should probably answer number 5 before you answer number 4 so you can answer these. In order for, so we're going to do number 5, sorry. In order for them to be the same pigment, they need to be the same color and approximately the same RF value. So keeping that in mind, you're going to look at number 4 and you'll say which spot they are. So like spot, I don't know, I'm imagining in spot 1 and 2, they'll have, so that'd be like 1 and 2, and then I would say that these two are the same. So the blue, oops, wow, can't spell. And then I would put the RF value. According to my calculations, the RF value is like 0.908. And then I would do that for the rest of them as well. Now, just because they look like they're the same doesn't always mean they're going to be the same, because look how much lower this one is. You know, it's probably not going to be the same number as that. It's probably going to be pretty far off. And you'll notice here, I don't have any units, and that's because whatever units that ruler is in, you'll have something like centimeters divided by centimeters, which equals 1, which is in a unit. But anyways, it gets rid of the units, so no unit right there. All right, the next part, saturated solution. So remember the NaCl solution you had? It had, this is gonna be a really bad drawing, but it was all in here. So there's like your liquid level, and then it had all these crystals on the bottom. So a saturated solution, and I'm sure you can look above in the reading, is going to be a solution that can no longer hold any more of what is dissolved in it. So in the case that you guys are going to be dealing with, the saturated solution is going to be a sodium borohydride, not hydride. And it'll be 300 mils, and then you'll have some borax on the bottom down here. And after stirring and everything, no matter what you do, you're not going to be able to add more borax to it unless you heat it like a lot hotter and then add more and let it cool down, but then you get super saturated, so don't worry about that. But just look above or even Google what a saturated solution is to get a perfect definition there. What container will you grow the borax crystals? I really want you guys to read the prelab, so I'm not going to give you the direct answer there, but I'll tell you it's definitely not an evaporating dish. Or a watch glass. So you have 2 options. So what's the chemical formula for borax? That is going to be, and it's in the reading above as well, but Na2B4O7 dot 10 H2O, and that's because it's a hydrate. How much borax will you add to 300 milliliters of water? I read that wrong. But anyways, how much of the borax will you add to 300 mils of water? Well, it says in the reading above again, 3/4 of a scoop. What does that equate to? I don't know. It's just whatever they have out for scoops. 3/4 of one of those. And then what is the purpose of the pipe cleaner? So what'll happen is draw some stuff down here. So you'll have your pipe cleaner. I think last semester I actually made, oh yeah, it's sitting right here. I actually made a Pokeball. And mine looked like this. And then I had my string. So here's the unknown vessel that I did my borax crystal growing in. And then I had my string tied right here, and then it went around the stick that you guys will be hanging it off of. But anyways, so use this pipe cleaner. And the crystals are white, they don't look like this, but it's actually going to be a base for the crystals to grow on. And depending on how saturated your solution is, you might start to see stuff grow. I think I left mine in for something like 2 weeks. And but right away, mine was really saturated. I had crystals start to grow on it. And by the time I was done, mine looked more like just this. And then like one little area that didn't have crystals, like the whole thing filled in. But anyways, that's what the purpose of the pipe cleaner is. The pipe cleaner is where you're actually going to be growing your crystals on. And that's this Pokeball shaped thing right here. But yeah, so cool. It's only a 12-minute video, getting a little faster at it. And let me know. I'll answer any questions you have in regards to this on Tuesday. And for those that went to the library to go get the packets, thank you. I talked to my boss. He didn't know where they were. I gave them to a worker, and they were sitting near his desk, but nobody told him about it. And yeah, so like, he knew about the packets, he just didn't know exactly where they were. So sorry about that. And yeah, I'm looking forward to seeing you guys on Tuesday, and I'll be there for the whole lab. And yeah, have a good week.